I'm Shlomo Dubnov, and the long title is In Fleeting Moments. So I don't know how fleeting will be this lecture. I hope something will stay around. Recomposing Prokofiev with deep neural networks. So this is a work. So I'm from UCSD. I also direct a center called CREL, Center for Research in Entertainment and Learning. So kind of going between music department, we have this wonderful facility in the concert hall, and then the Qualcomm Institute where the research center is hosted. Just a little bit more about me. So, these are books that I wrote, The Structure of Style, with two co-authors. Cross-cultural multimedia computing. So I'm kind of like computer science and music. Basically, I have it. I studied composition, and then my PhD is in computer science. So I'm kind of really interested in modeling, formal modeling, computer modeling, and machine learning for music. But we also do stuff related to dance. So we have papers in multimedia, where we actually use our machine learning models to analyze human gesture and human movement, and also once in a while come back to my artistic side. I'm very interested in participation, human participation with computers or with performances. And speaking about data, how you can basically augment an existing story and make it much more inclusive and much more open to interpretations, because I think meaning comes not necessarily from the message you deliver, but by the way you interact and the way basically you come to some kind of a common ground on communicating about the topic. So there is no one truth really, and I think this is an interesting question to discuss, because we sort of like think about data, think about computers as something that will actually give you the answer. You give a query, look at my kids, You ask them something, oh yeah, Google, that's the answer. Well, there is no answer. The answer is actually negotiating the meaning of these things, and it depends on your context, on the cultural background. So in that experiment, there was a piece that, I don't know how to say, designed, wrote, composed, where public were also participating through a back channel with their laptops, and they had additional information on every scene that happened. But it could be also pretty overwhelming. And I would say my maybe greatest accomplishment, we had a belly button circus with my kids. So some of us actually enjoy doing stuff totally outside. But again, 1, 2, 3, 4. The 4 in the middle are mine. That's myself there. And I have a couple more. All right, so creative technology and AI. We introduced the idea of creativity, and the artificial intelligence and information technology are supposed to be the big revolution that changes the way we perceive the world, and it combines AI, big data, and maybe other tools. But the question is, well, how can we sort of get in touch? The notion that the robot or the machine has its own states, its own intelligence, and human maybe has to be understood also in some formal terms if we want to create this communication. It doesn't mean that there is necessarily alienation or that the robot is actually representing something which is different from the human. I think the robots can help us get more of our own human expression. So the things that I'm interested in is like machine improvisation. So how can you improvise with a machine and help yourself, be more creative, more inspired. And now the machine, you expect it not only to be totally experimental, but maybe learn a specific style, maybe your own style, augment your own way of thinking. Aspects of music meta creation. So what is meta creation? Well, I mean, if the machine today can capture a lot of knowledge, a lot of style. You don't even need to program it. As I said, you can just play in or present a database and it will kind of find the rules. You still want to specify something. So you can be meta-creative. You can specify what you want from that machine to do, and it will fill in the details. So the creative human-robot interaction actually can be done in different ways, and we're also looking into ideas of, the machine has to understand you, so it's computer vision, computer audition. You expect to communicate with that machine in natural ways, natural interfaces. And the topic of experiential computing, actually, I think is an emerging field where the question of computing becomes not so much creating more data or using your data to benefit maybe some third party, but it creates an experience. And that experience that we had is with humans or human with human could be augmented with a machine, or sometimes may be confused between, like, we don't know. We heard the lecture, just the one before, where people, judge the machine creativity better than human creativity. So I think at least the way I like to look into this, because as I was actually teaching information theory, I was in the engineering department before, well, what is information and code? We speak about cultural codes, we speak about computer codes, and we can speak also about code as encoding of information. So we can actually extract information by encoding, and there are these very sophisticated algorithms, and machine learning is part of what we do. But before that, with Claude Shannon, the whole idea of information technology, one of the big revolutions that were on the slide before were actually the ability to transmit and encode information. So if you have data, you can actually extract the structure from that data and create your code book. That's how compression works. That's how you can take your text file and run it through a zip or Lempel-Ziv algorithm or any kind of a compression, and suddenly become smaller. It still has the same information, but it's just much smaller. You can, of course, do it in some kind of a lossy way, and we all send videos, and we know that it's not a full bandwidth. We actually compress it in some way, but it might be good enough for our purposes, maybe distinguishable from the original, maybe indistinguishable, depending how well you compress and how many bits you want to send. So the idea is that computer can extract structure. And I think there is another deep idea in information theory, is that if you actually extract all the structure, all you're left is with noise. Because if you're not left with noise, you can extract more structure, right? So kind of the incompressible thing is noise. So, in mathematical terms, but this is more for illustration purposes, there is something called a typical set, which means these are the things that will actually typically happen. If you flip a coin enough times, and if it's a fair coin, typically you'll have 50-50 chance. Or if it's biased coins, 90 to 10, let's say, you'll have 90% of one side, 10% of the other side. If you look enough, you'll get typical things, and things which are not typical usually don't happen. So you can extract the structures. If you look at enough data, you actually kind of grasp the idea what it is about, what is the structure. So I think one of the early experiments we did, that's almost 20 years ago, during the time I was a researcher in France in IRCAM, which is Institute for Acoustics and Music, and we kind of started doing these experiments of taking a sequence, taking a musical piece, and running this through a compression algorithm, Lempel-Ziv. And this is, it says LZFI. You take your data, you think about this as a string, as a text, you run this through a compression algorithm, it builds a tree. What the tree contains, basically typical phrases, because that's how it's encoded. It's encoded in a way that it always finds what happened before, and instead of really sending the whole string, it sends just a pointer to something that happened before. And that's how it saves information, or sends bandwidth, saves bandwidth. So instead of transmitting it, you just create this tree, and then you do a random walk on this tree, and you sort of recreate your piece, or basically you think about this as an information source, and you recreate new instances of that same piece just by decompressing it in a random way. So I think this is kind of a central idea that inspired a lot of this machine improvisation work, and there'd been a bunch of machine improvisation systems that emerged from this simple algorithm, basically, of parsing your data using a compression algorithm, and then using that codebook and doing a random walk on that codebook. And this is, I think, a much more intuitive approach than thinking about statistics and Markov chains and all these kind of fancy words. But I'll speak in a second about deep learning, because I think now we have a lot of revolutions that actually allows us even to do more with this kind of insight. So kind of just to give an idea, this is Mimi's system, Elaine Chu. She was I think in USC, and then moved to London. Now she's back. Now she's in IRCAM actually. So for instance, this is a different implementation of our ideas, and the performer is actually playing something. I hope we have sound here.
Did you plug in the?
Well, it's HDMI. I have to plug it separately. Okay, let's. Perfect. Okay, that'll be better for this. Do you have that? No. Do you have to redefine then? Well, let's see how if it works. It does. So the musician improvises. It's a free improvisation. The computer actually tries to extract patterns from what he improvises and then plays them back in a different way, in different order. Now, in order to help the musician plan what he's doing, he actually sees the future of what the machine is going to play. Sorry? Oh, sorry. So in order to help the musician, now we have a feedback. So in order to help the musician plan, because this is kind of capturing his style on the fly, the machine actually shows, or the screen shows what the machine is going to improvise in the future. So it kind of learns his style, but instead of having a total surprise, in some sense the musician generates the materials for the machine, but then the machine tells sort of visually ahead of time, this is what's going to happen, so he can plan his own improvisation later on. So the musician becomes subordinate to the machine in some sense, even though the machine tries to augment him. So this is a little bit of a kind of an abstract type of music. This idea of kind of duets between a human and a machine, where the machine has some sort of autonomy, but that autonomy is not totally kind of pre-programmed, and in some sense it's inspired by the musician. This would be, I would say, maybe some early, that's one approach to doing these machine improvisation systems. So I think the question that we want to deal with is, what's mechanical creativity, or what's machine and creativity? In order to do this, we kind of need to maybe understand about our own creativity and what we expect the machine to do. So Margaret Bowden defined these three types of human creativity. A search in space, or exploration. So if you know that there is a predefined style, some kind of a set of rules and conventions that governs the way you create art, or create maybe even scientific discovery, but you don't go outside of boundaries of your domain, the machine can help you explore. It does a search for you. So it can always generate stuff that you haven't yet explored, even though it exists in the domain. Combinatorially, you can fuse styles. You can basically have two different things, and you can come up with combinations that haven't existed before. And the last one, transformational, let's say like going from classical mechanics to quantum mechanics, which means you totally redefine your worldview in view of new theories. This is maybe a little bit too much to ask for the machine. But at least the two first ones we definitely explore. I mean, the machine can learn, domain of musical expression and create new examples. I've also, written pieces where we took a database of different styles and created music that blends or jumps between different genres. So I think the question is, what is the goal of computational creativity? So you could say it's to model, simulate, or replicate creativity. But what is the purpose of this? Well, one, I think it's an interesting engineering problem to construct a program that's capable of human-level creativity. Another one is really to understand better our own creativity, so we can formulate some kind of a algorithmic, but doesn't have to be algorithmic deterministic. It can be a machine learning aspect, so we understand how we behave as humans and what we think is creative. And then the third purpose is actually interact with creative programs, design programs that can enhance human creativity without being creative themselves. So I'm kind of deliberately lowering the expectations and trying to define the field as something that actually helps humans and allows us maybe to have a mirror that reflects upon ourselves, our own capabilities, without going into the idea that machine will take over. So just kind of some reactions for how people work with these systems. It can be a lot of fun. So this is an example from one of the early improvisation systems, and this is very abstract. So Bernard Luba, he's a French musician improviser. He really works a lot with the systems, and then he inputs his stuff, and then just look, how he reacts to what the machine now suggests him to do.
Ça va être chouette, les mecs de 30 ans, ils sont écus, ça va toi, ça va, je parfois, tu dimanche, j'adore cette musique.
So he definitely got inspired. Some other things, we can actually load a database or a set of music, and can improvise with it by querying this data set with something that is kind of a remix, but it's generated not by jumping a needle on a turntable, but actually playing music. So I can just show another short example of, I hope I'm jumping just to a random location in that piece. So this is me trying to improvise with one of the machine improvisation systems that we have been developing. And the reference is Stravinsky's Rite of Spring. So. See that I'm playing way fewer notes than what you hear, and some of this is basically me well, you know, I'm relatively familiar with the piece. Of course, it's a very complicated and orchestral piece, but you know, kind of, I knew like what segments, if I improvise, hopefully it will react in a certain way. So, let me go. So in this case, you know, the machine wasn't learning my style on the fly, like in the first example. It actually took a data set, took Stravinsky's Rite of Spring, and I could query this through my improvisation. So in this case, there is really more of an interaction than machine kind of learning something and then spitting this. And this is kind of the work that is the title of this talk, where we want to use machine learning deep neural networks. So what do deep neural networks do? They are able to kind of encode and decode stuff, but the important thing is that there is this random element here. So we use what's called so-called variational autoencoders. And on the left, this is the original, so kind of the idea of input. You query a data set, you query a model with another input, and in this case, actually, the machine learned on a different set of musical examples from Stravinsky. Sorry, this is Prokofiev, Sergei Prokofiev. I don't know why I always bring the Russian composers, but so it learned on a different set, and then it took Prokofiev's Vision Fugitive, or I mean, actually, the name comes from Konstantin Balmont, who was a Russian poet, and when he heard these pieces, he wrote, "In every fleeting vision, I see worlds filled with fickle play of rainbows." So that's where the Fleeting Visions name of these pieces came. These are short segments, and they have a lot of structure. So the interesting other question is really, when you take a lot of data, you kind of average everything, and then you can generate this machine that will keep generating more and more. But we can express ourselves in very limited ways. I mean, the original piece, you know, you start playing it, it has a motive, and then it has development, and then there's the conclusion, and it's really beautifully structured. And the smaller pieces are actually much harder to write. I mean, the miniatures that actually capture your idea. I mean, with big data, you create this model and can keep generating for you, right? So, but you actually want to tell a story. You want to start with something and end with something. So, I think we're kind of running a little short on time. But the idea was, so, you know, kind of using these models and plugging them into a different musical piece, and then that results in a different new composition. And it could be, of course, printed and notated. It's a little bit like the previous example, but it was done not by me improvising, but taking a different piece as an input and generating a new piece. But here there was more of a style transformation through this neural network. And I don't know, maybe I kind of just play a little excerpt of how it sounds, because it sounds, I don't know if you're familiar with it, it's kind of a neoclassical style. So somewhere here, just a sample. The goals, or maybe some topics to think about in the panel, at least my suggestions for real questions is, well, how do you combine research and creation? I mean, how can we build teams where artists and scientists are equally credited, acknowledged, because we have different approaches. You know, engineering is done in teams. Artists have their own voice. So how do you bring them together and, you know, make them feel equally valid? I mean, it's not that the artist writes a demo for a new software, and it's not that the software is written to basically be kind of the assistant, whatever, the musical assistant or the creative assistant for an artist who actually owns all the kind of creative part of the project. No, I mean, there's a synergy which is really hard to negotiate. And of course, also in terms of funding models, lab culture versus studio cultures are very different. And I think, I have to deal with this just because of, whatever the administrative duties are of running a center. And I think what we talk about now is about experience now. And the dialectics are not material dialectics or anything like that. It's experiential dialectics. I mean, who can give you more experience, more value to your life in some sense? And it's not about owning means of production or not. It's really kind of creating this idea. And if a machine gives you more experience than a human, then the humans might need to work harder, really. So, so it's the art not in the age of mechanical reproduction where somebody owns the means of reproduction. Machines are creative, and I think this is a big challenge. So the last thing, we can invite you. We have another symposium coming up, which is really industry-oriented with games and Cygames research, Adobe research, Huawei, which is a toys company. So we're kind of trying to bring in companies and help us with that negotiation. So thank you. All right.